Good morning to all and welcome to this webinar on geothermal energy. Today we'll have a discussion following the publication of a new report by the IEA in December, The Future of Geothermal Energy. At Euroheat and Power, we believe this report brought a serious analysis on the benefits of geothermal energy and ways to unlock the potential. So this morning we'll focus on heating. In Europe, you know that over 30% of final energy demands go for space heating and hot water preparation in buildings. As you know that 75% of these demands are met with boilers using fossil fuel. So in this context, geothermal appears as a very strong option to decarbonize the heating sector. Looking at district heating, it will provide the infrastructure to scale up renewables in cities. Today, geothermal represents 2.5% of the fuel mix, but we see many countries with very high ambitions for geothermal district heating, in particular Germany, France, Austria, Hungary, Denmark, and the Czech Republic. In a recent study, Aalborg University identified a potential of 2,000 terawatt-hour of heat sources from renewable and waste heat that could be used to fuel the growth of district heating and decarbonized on the heat market. So this is the picture you can see on the right side of the slide. And this is equivalent to the heating demands from buildings by 2050. You can see on the slide also a very high potential, over 500 terawatt-hour for geothermal, considering several layers. In a new study, also from Aalborg University that will be released very soon, well, they evaluated a technical and economic potential for geothermal in district heating between 100 to 200 terawatt-hour a year, depending on the district heating scenario. Well, of course, meeting this potential for geothermal heat will require district heating to increase its market share from the current 13% at European level to at least 55% by 2050. This is also possible with adequate measures and funding. It means a growth of over 5% a year from now until 2050. And now to start the discussion, I will turn to François Briens from the IEA. François is one of the authors of the IEA report, and François will share with us the key learnings of the report. So François, geothermal is too often referred to as the sleeping giant of the energy sector. So can you tell us how can we wake up the giant? Please, François.
Yes, thank you very much, Eloi and Eloi and all the Euroheat and Power team for your invitation and for this opportunity to present our special report on geothermal that we published just last December. So yeah, my name is François. I work as an analyst in the Renewable Energy division at the IEA, and with many other colleagues, I contributed to this analysis. So yeah, geothermal is really receiving increasing interest lately, and this is in part related to a few successful demonstration projects that experiment new approaches. And the question is to which extent this success can really change the game and what is needed for geothermal to scale up. And this is what we try to investigate in our report, and that's what I will try to summarize in the presentation that follows. This presentation will extend slightly beyond district heating, also because electricity is part of the game in the equation. So just to start, geothermal energy is the heat derived from the Earth's subsurface, which comes partly from the planet formation, partly from the decay of radioactive isotopes within the Earth's core and mantle, and partly also from solar radiation accumulated at shallow depth. And this heat can be carried to the surface by fluids, to be used directly or upgraded with geothermal heat pumps, or to supply industry, buildings, agriculture, and also district heating networks, or it can be converted into electricity. So it is a very versatile energy source, and it is also a very secure source in the sense that production, doesn't depend on climatic condition or seasonality. And geothermal is a dispatchable baseload source, basically. So if you look at the figure, you see that the majority of geothermal heat consumed today is in the form of heat, especially using geothermal heat pumps and district heating, and that electricity represents 1/5 of the final consumption. If you look on the right figure, you can see that geothermal use is unevenly deployed across regions, with China, which is the biggest player for heat, and the US, Indonesia, and Turkey, also the Philippines, which lead for geothermal electricity. Except for a few countries, say for instance, Iceland or Kenya, geothermal energy is only a small share of the energy mix. And at the global level, this is less than 1% of total energy demand. So it's not a lot for now. But if we now look at the future of geothermal in the next decades, and at the IEA for that, we use different scenarios. One is steps for stated or existing policies. The other one is APS for announced pledges. So if we look forward, whether under current policies or announced pledges, we see the sizable perspective for conventional geothermal growth, both for electricity on the left figure and for heat on the right. Although if you look at the lines and on the right axis of both figures, you see that the share of conventional geothermal is projected to remain small, still below 1% in both cases. And part of these limited developments relates to the dependency of conventional geothermal to specific geological settings, like hot aquifers, for instance, where water is trapped in porous rock and forms a reservoir, which is heated by the surrounding rock. So you need to meet conditions of temperature, of rock permeability, and of fluid, and it is not the case everywhere, and meeting these conditions is uncertain, and it's a risk factor for conventional project development. But now we are seeing new approaches that do not rely on natural hydrothermal reservoirs. They use techniques and know-how from the oil and gas sectors, like hydraulic fracturing, directional drilling, etc. And they are currently tested through pilots and early commercial projects. Generally, they fall into two main categories. We have EGS, enhanced or engineered geothermal systems, and CLG for closed-loop geothermal, which is also called advanced geothermal or AGS in some cases. And in EGS, you expand existing reservoir or you create new ones by drilling deep wells and by opening up or creating fractures in the rock. And then you can circulate a fluid that absorb and transport the heat to the surface. And we can mention in particular some projects like Utah Forge, Fervo, Project Red, and Cape Station, which are in the US, and the Hudson project in Switzerland right now. For CLG, for closed loop, it is different. You drill and seal deep, large artificial closed-loop circuits in which you circulate your fluid to gather calories and to break them up. And this consumes less water, you have less risk and uncertainties, but it requires massive drilling distance to have enough heat exchange area. And so it has high drilling costs. And the main project currently is the EVOR Europe 1, which is in Germany. And in both cases, it means that you no longer depend on natural reservoir, and you could exploit geothermal energy almost anywhere. Temperature increase with vertical depth, so temperature conditions can be found by just drilling deep enough. So we ask ourselves, what potential does this unlock? And for this analysis, we have partnered with Project Inner Space, and they do an amazing job. I really recommend to check their website. So they modeled the technical potential based on the heat content of the subsurface. And here are a few results that I will present. So here is a map of the energy potential above 150 degrees at 2,000 meters of depth. And this is where you go at 4,000 meters of depth. And this is when you reach 7,000 meters deep. So what you see that if you can go deep enough, geothermal potential is almost anywhere on the planet. But if we look at number, also, if we consider just for electricity, and if we consider a potential at a cost that is below 300 USD per megawatt hour today, then the technical potential is order of magnitude above current global electricity demand. And you see that most of the potential actually lies below 5 kilometers deep. So you need to go deep to get it. But then if you can do that, then it becomes massive. And for heat, this is the same story. Here on this slide, we consider only heat from sedimentary aquifer that can be extracted below 50 USD per megawatt hour. And just in Europe, you have about 230,000 exajoules of usable heat at 90 Celsius degrees. And this is 30 times the annual district heat consumption in the region. And as you can see on the left, the potential is even much greater at lower temperatures, which new district networks can use. We also made additional analysis with Project InnoSpace, looking at the spatial overlap between geothermal heating and cooling potential and the location of urban centers. And I don't have time to go through it now, but you can check in the report. So this was the technical potential, but not the economic or market potential, which will depend on how fast the cost of next generation geothermal can fall and become competitive. And on this topic, we need to say something about the oil and gas sector, because there are many overlapping competencies between oil and gas and geothermal, and not only for drilling techniques and well stimulation, but also for project evaluation, planning, management, surface facility construction and maintenance, for operation, for monitoring, and so on. And we estimate that about 3/4 of required investments relate very closely to oil and gas industry skills and expertise, and that leveraging this expertise could make a big, big difference to reduce geothermal costs. On this figure now, so on this figure, what this figure shows here is for EGS, for enhanced geothermal. And depending on the knowledge transfer, you see that you can significantly bring costs down, and you can cut them by almost 80% in the base case, which will then make it one of the most cost competitive, clean and dispatchable technology for electricity. And so if we assume such a case with rapid construction cost decline by 2035, this would bring the LCOE close to 50 USD per megawatt hour. And it's a strong assumption, but it's not something that is unseen in the energy world. If you look at the cost of solar PV in the past 10 years, for instance, it's the order of magnitude that we saw. So if we consider such cost decline, this unlocks over 800 gigawatts of next generation geothermal electricity by 2050, and that will represent 8% of electricity supply at that date. And in addition, it will also unlock a lot of industrial heat and CHP capacities. So for industry, next generation geothermal could become competitive for large plants with process heat of 100 to 200 Celsius degrees mostly. That's where heat pumps are still operational and competitive, but in higher temperature, it's a bit more difficult for them. And then it could displace about 3 exajoules of fossil fuel in the industry sector by 2035, and that would be 10% of sub 200 degrees industrial heat demand. And of course, there are challenges related to investment cost and to long planning time. And we think that industrial cluster strategies can really help with that by mutualizing cost and procedure and so on. And for CHP, for district heating, in our low cost scale for next generation geothermal, average investment costs are assumed to fall to 3,500 USD kilowatt by 2035 and further down by 2050. And if we account for retirement of all CHP plants and for the efficiency impact and demand and so on, in this case, our modeling suggests that the share of next generation geothermal in district heating globally could rise to nearly 5% by 2050. And in some regions like Europe, for instance, it will be up to 10%, and it could be even more in the US. However, if we assume a medium cost case, that's the red line on this figure, with more limited cost reduction, then the technology remains too expensive to compete in district heating. And the growth is much more limited. So widespread adoption in district heating is only likely if the cost can fall below 4,000 USD per kilowatt. And I was already a bit too long, but just to conclude, so the technology is promising. The big challenge is really to scale it and to make it competitive rapidly. And we identified a certain number of policy priority areas. I won't go through all of them here, but I would like just to mention a few ones. First one is the importance of building geothermal specific targets and roadmaps, because currently we have more than 100 countries with policies in place for solar PV and wind, but we have much less for geothermal, like just 30 countries have policy for geothermal. And there is a lot of work to do to streamline permitting in many jurisdictions. while still maintaining a high environmental standard and really actively engaging local communities in the process, because that makes a big difference. We also need to think of the need of training and skills to meet the growing workforce demand if we want to really scale up, and also to strengthen institutional expertise and the capabilities of public authorities. That includes for permitting, but also for heat mapping, for planning, and so on. That's everything which is district heating related in general. And I would like to stress also the importance of de-risking schemes, which are absolutely essential. And we also need to work on appropriate remuneration designs that provide long-term certainty and that can really remunerate the system services. And there are a lot of you more that I really invite you to go look in our report. It's free, available on the IEA website. And I stop here because other speakers have a lot more interesting things to say again. So thank you very much for your attention, and I leave the floor back to you, Eloi.
Yeah, thank you very much, François, for all these insights. I'll get back to you because I see there is already a question for you. Thanks again. I would like now indeed to follow up with our next speakers. I will start with Alexander Walisz from Wien Energie. Sasha, please, the floor is yours.
Thank you. Now I got myself unmuted. Heartily welcome from my side. I'm working at Wien Energie, and I will give you now a much more local perspective on geothermal. But it was very, very interesting and very, very thrilling to see the global perspective. Thank you very much for that. So what are we doing in Vienna? First of all, Vienna has also the clear path to climate neutrality in 2040. And looking into a large city as Vienna is, and Vienna is a growing city, we see that on the building sector, we have a lot of work to do to reach the climate neutrality in 2040. We do have more than 600,000 households using fossil fuels at the moment. Mainly it is gas. We have 440,000 of them having the individual boilers inside of the flat. So it is a huge task to get them centralized, to get the buildings switching their heating system, and also it is very, very important to renovate a lot of buildings and a lot of flats to lower the energy demand. And doing it, so there are two options in Vienna, what we think that can help a lot. This is heat pumps in smaller buildings and in where the area is more widespread, and it is district heating, which can help to switch from gas, from oil, to district heating, to renewables, so that we can reach the climate neutrality. And to do so, we also need to look into our district heating system. So now our district heating system is very efficient, but still in its efficiency, it is related on fossil gas too. We are using the fossil gas very, very efficient in our CHPs, but nevertheless, to reach the climate neutrality, we need to make a switch towards renewable and waste heat to get there. And we have made an assumption and looked into it very deeply, how we can do it. And what it points out is very, very important potential for us in Vienna is the expansion of geothermal energy, which I want to highlight out today. The others are also very, very thrilling and very, very demanding, but today it's about geothermal energy. And so there we see that we have about a quarter of our energy coming in the future out of geothermal energy. That is our plan. So therefore, we were developing our first project of geothermal, and we started in 2015 to be honest, we already started some years ago, but there we also had one drill, but this failed, and this failure took us several years to come into to start again. So therefore, it is very important that we now do not fail. Therefore, we started a very deep research, starting with 2D seismic and with 3D seismic. And in 2020, we had the geological model available for Vienna and the surrounding of Vienna, where we saw that there is the potential for water in the deep surface, which made us very happy that we can start on with our projects, and there was the start of the planning, and also we started there with the commissioning. And so to stress, we now are in the phase that we started drilling in December, and therefore it took us 5 years with the planning and the commissioning. And one huge step was also, which I want to point out, is that we started a joint venture with OMV, the local oil and gas company, the Austrian, which really made a huge step forward for us, because there is a lot of knowledge for drilling, and this helped the projects to come along very much. So now we are in the phase that we started drilling for our first plant. It will be, we assume that it will have about 20 megawatt thermal. We started the first hole in the mid of December, end of December 2024, and so the first 3,000 meters are already done, and now the evaluation of the capacity starts. So, and we want to gain more information for the next holes we want to drill then onwards, so that then when the drills are ready, then we think that we will have the possibility to make the surface plant we need to, and the connection to the district heating. So overall, we think that we need about 90 million euros of investments. That's not only the drilling, that's also including the heat pump, which we need, or we want to have, for the temperature boost, to raise the temperature from 100 degrees to higher degrees if we need it in the district heating system. So not all the time, but in the times where we need higher temperatures, then we want to boost. And other effect we want to use with the heat pump is lowering the return flow, so that we can raise the capacity we are using from the geothermal energy. Yeah, and this should be just the start of the projects in Vienna. We are planning about 200 megawatts of geothermal energy capacity, with about 7 holes, 7 plants we want to build up. Yeah, and one big thing is also to obtain the authority approvals and the permissions. And we need to go to look into the water law. We need to look into the mining law, construction laws, and industrial plants law also apply. And we need the landowner consent of each landowner above our drillings, no matter how deep it is. In this case, we had a big luck that no one complained, and that no one went into it. Otherwise, it would have cost us several more even years to get all the landowner consents. In this case, we had luck and no one, and we got we got it. So therefore, in overall, we see a huge potential for geothermal heat. It's very important. The geothermal energy delivers renewable and, what is very important, also affordable heat for the citizens and for the district heating system and for the district heating customers. To do so, investment security is fundamental. We all are companies, and we need to have some kind of security of investments, and it took us a very long time to get the permissions also inside of the company to make these investments. Yeah, and therefore de-risking is very important, and commissioning procedures are really one key point also where we need to step on. So thank you.
Thank you very much, Alexander. Renewable and affordable heat for citizens. It is indeed what geothermal is about. So thanks again. I would like now to move to our next speaker. So actually we'll travel 400 kilometers southeast of Vienna to the city of Szeged. Please, Tamás, the floor is yours.
Thank you, Eloi, for having me on this panel, and I'm very happy to come after Alexander, because indeed this is quite a similar project to what he has been talking about. I'm going to talk about how we switched the district heating of Szeged to geothermal. Szeged is on the southeast part of Hungary, and indeed it is close to Vienna. It is a smaller city, a medium-sized city actually, 160,000 people. It's mainly a university town, and the district heating of Szeged provides heat and domestic hot water to 27,000 apartments and about 400 non-residential end users. So this is, like I said, a medium-sized operation that was built entirely on fossil fuels, natural gas, basically. Setav has an installed capacity of 200 megawatts. The total energy output is 800,000 gigajoules. So this is what we are dealing with, and our intention was to switch about 50%, 50 to 60% of this to geothermal. The company was actually the single largest CO2 emitter in the city, and the main reason behind the project was first environmental. In the meantime, this has turned into a security of supply issue too. So now this is a twofold project that aims to tackle both problems. This is the southeastern part of Hungary, and what you see here is that in a 50 kilometers radius around Szeged, you have 9 municipalities who utilize geothermal for energy purposes. This is not counting balneological purposes. We have a lot more of those around here too. These are smaller cities, smaller towns basically, and Szeged is by far the largest. These were the first steps in Szeged. We commissioned the project to have geothermal in the heating of the university buildings. These are hospitals and teaching buildings, apartments, and this two systems have been operating for more than 40 years now, actually, or 15, more like 15 years now, and they proved that it is indeed economically viable and a safe operation in a densely populated area like a city like Szeged. What we are doing is we are drilling 9 production wells. These are screened at around 1,700 or 2,000 meter deep depths, and they provide 70 cubic meter per hour water at 90 degrees Celsius. So this is perfectly suited for our district heating system. This is just not enough for electricity production, but for direct use, this is a perfect match for us. the wells are positioned as close to the nearest heating plant as possible, but still, as it is a densely populated area, it was quite a challenge to locate these or to pinpoint the location of the wells, and we needed to lay 30 kilometers of new insulated pipelines towards between the production wells and the heating plants. Now, the geothermal water does not enter the apartments. It is utilized, its energy content is utilized in the heating plants via heat exchangers. And after that, actually 100% of the water is being re-injected into 18 injection wells. So we have 2 injection wells for every production well. This is a upper Pannonian sandstone reservoir. It's fairly easy to get geothermal brine out of. It's not really a technical issue. Injection is, however, and we have to be careful. We have to maintain a low pressure, and this is for safety purposes mainly. These are the 9 heating circuits that we introduce geothermal to. Actually, this is one of them. This is called North Town area, and what you see here is a fairly standard circuit for us. It serves 4,000 apartments, 76 public institutions, and it used to use 4 million cubic meters of natural gas every year. Now it is down to 2. So basically, it's a 50% cut in both natural gas use and CO2 emission. What you also see on the bottom right corner of the slide is one of our larger heating plants, and I'm going to show you quite a few of these, not too many, but a few of these. We teamed up with a local NGO, a local environmental group of young people, and we actually dedicated our buildings to their environmental purposes, so to say. And these buildings, these heating plants that were quite ugly and really not very nice sites have been turned into environmentally educative buildings, so to say. This is Makkosháza, another area of ours. It has 3,000 apartments, and what you see here is that the drilling rigs are actually quite close to the apartments, to the living quarters of the people, and it did indeed cause trouble and a problem when these wells were operating 24/7 for months at a time. And we really had to reach out to people, and that's what you see at the bottom of the slide, that we usually invite citizens to visit the rigs and actually educate them about what is going on. Another area, this is the uptown, another environmentally decorated of our heating plants. This one has hedgehogs on it, and this is the one that I would like to highlight here. We actually painted the heating plant to a giant TV screen, and what we did, we offered free movie nights throughout the summer for the good people of Szeged, and they came in large numbers. Actually, there were 400, 500 people at a time. And we showed them blockbusters, Mamma Mia and the like, but before the movies, we showed them short geothermal programming, just like 5 minutes about what we are doing, and this was really we really think that this was a successful attempt to educate the public. Once again, school children visit one of our operations, and this is another of our area. Okay, and now this is the inner city. Actually, the mayor's office and the town hall is heated with geothermal, so it is really a widespread operation in Szeged. This is our smallest heating circuit. Now we are into R&D also, because with 9 production and 18 injection wells, there is quite a lot of data that's coming up, and we are teaming up with professionals from the University of Szeged and other research teams, and we are very much interested in international cooperations. Szeged is a great demonstration site. This operation is ongoing, and one can visit and see, and also test new equipment or poll the public or whatever it is that we can offer our site. We are ready to. Szeged has a good international coverage also. It's a fairly standard city in the sense that we have a gas-based system that is being switched to geothermal, and many municipalities are following this step or are thinking about it, and we certainly hope that they can learn from us in this respect. Thank you very much.
Yeah, thank you very much, Tamás. I think Szeged, like Vienna, I mean, these are perfect examples of how geothermal can help bring heat home. Thank you very much. And now, after utilities, I would like to turn to Asbjørn, and I'm very happy, Asbjørn, you are here this morning, and you will share insights on the opportunities and the challenges from the perspective of energy, which is developing projects with geothermal across Europe. Please, Asbjørn, it's your turn.
Thank you very much, and good morning all. And thank you very much, EIA, for doing this report and throwing so much light on the potential of geothermal. We really appreciate that. Energy, yes, is a company that finances, develop, construct, and operates geothermal plants for district heating companies, so that you can say we provide the heat as a service. We only invoice if we can provide the heat. It's like a leasing model. And we have projects in Denmark and Poland and Germany. Yes, please change the slide. And just a quick look, this is one of our projects. It's in Aarhus. It's the second largest city in Denmark, 350,000 inhabitants, and 90% of them on district heating. I won't spell it out because many of the points are the same as Alexander and Tamás just mentioned, but just three things. First, this is a large district heating network now, only running on waste incineration, or only to run on waste incineration and geothermal as baseload. So in the future, no coal, no gas, no biomass, but waste incineration and geothermal as baseload. Second point is the same as yours, Tamás. Have a look at the dots. We have 17 wells, and they are spread over the city. And it's also a way to make the district heating network more efficient, because we can provide the heat where the demand is. It means that we can lower the temperature in the district heating network and make it even more competitive and energy efficient. And then the last point is, of course, now we talk a lot about conventional geothermal and next generation geothermal. And I completely agree with everything François just said, but I also think there's a time perspective. So next generation is next generation, but this conventional solution to geothermal, it's now. And if we change the slide again, thank you. You can see that there's a huge immediate potential for combining district heating and conventional geothermal if you look throughout Europe. Actually, in 14 of the EU member states, you have subsurface conditions needed, and you have large district heating networks. So if you want to decarbonize big cities like Warsaw and Berlin, you can use a substantial amount of conventional geothermal already now. And the same goes, of course, for the cities where we are working in Poland, in Łódź and Poznan and so on. So there is a time perspective. And when we talk about climate change and energy security and energy independence, time matters. So we can do something now if we want to. Yeah, that's just to say something about the potential. If we change to the next slide. Then there's, of course, also something that we need to fix if we want to get more conventional geothermal district heating faster. And it's just look at it as a picture. But we mapped out, of course, all the permitting that we need to make our project in Poznan come alive, all the authority interaction that we need. And this is actually in a city where the city wants a solution, the district heating wants a solution, and we want to provide the solution. And this whole system is not made because anyone wants to block geothermal. It's basically meant because no one thought about geothermal when the permitting system was designed. So this is a quite clear picture of what I would call red tape. And this is some of the things we could look into if we want more conventional geothermal district heating. And last slide, please. And if we look across all of our projects, and if I were to make a wish list for the heating and cooling strategy that Europe is now to prepare, and the geothermal action plan that the European Council called for just before Christmas, then these points would be high on my wish list. Of course, clear commitments and long-term thinking. We are talking about huge investments up front, and we are talking about depreciation periods of 30 years. And then you have a lot of unnecessary risk in there. Alexander and Thomas also touched upon it. But that is risk that are keeping private investors and private money out of this. So if you are to de-risk a project, the first thing you look at is already available subsurface data. And it differs a lot across Europe, whether or not you have access or easy access or even access to these data. Here, there's really something you could do. And then you can shorten and streamline permitting procedures as you just saw, and you could help provide plots in urban area. And then, of course, you should modernize and expand district heating as part of this overall heat planning that we are going to do in Europe in all major cities. District heating is the enabler for geothermal large scale and for other renewables and unavoidable waste heat, by the way. But it is so important that we get this infrastructure rolled out, because this is also a way to make access to geothermal energy cost efficient and sociable acceptable. And then, of course, keep putting the pressure on the phase out of fossil fuels, including biomass if it's only used for producing heat, lower subsidies or even remove them, and speed up decarbonization. And then there's been a lot of talk about risk insurance and subsidies. And I think it could be good with some risk insurance available across Europe, but it has to be done in a smart way. We have seen good things in France, but we have also seen bad things in other countries, including Denmark, by the way, where it didn't work. And we have seen risk insurance schemes where all the risk is put on the taxpayers. And if you do so, then you also get projects that should never have gone through. But if it can be done in a smart way, it will for sure speed up private investments in geothermal. And my last wish is, of course, access to low-cost financing. We have these schemes within the European system already, where you can have access to low-cost financing if you are in certain areas of Europe or if you do very innovative projects. But why not have access to low-cost financing based on CO2 avoidance? So how much CO2 can you take out, and then you could have access to low-cost financing? That would be my input for the coming heating and cooling strategy that is to be developed. Thank you, Eloi.
Thank you, Esbjørn. It was very rich. You mentioned long-term thinking in your last slides. Well, obviously, when talking about capital-intensive investments to explore, to drill, to deploy energy networks, businesses need a long-term perspective. And obviously, we also need an alignment of the different levels of regulations to speed up geothermal projects and to speed up the development of district heating. Thank you, Esbjørn. And I will now turn to Marco Baresi from Turboden. So Marco, you will give us an industry perspective, and in this case, from a leading producer of heat pumps and ORC solutions. Please, Marco.
Thanks, Eloi. Good morning, everyone. And I'm very glad to be here and to share the experience of Turboden. 1986, more than quite 40 years ago, it was the first ORC geothermal plant developed by Turboden. It was in Zambia, in Africa. 2026 will be the first project in operation, in large project EGS in operation from Turboden, the 100 megawatt mentioned by the EIA for the Fervo in the United States. So we have 40 years of experience in ORC and large heat pump in geothermal. But these projects are not related to the district heating, so are quite off topic for today. So that's why I chose another history for today. This project is in Germany. Is a project developed for Stadtwerke München and Sauerlach, and it is a 5 megawatt electrical geothermal project plus 4 megawatt thermal connected to the municipality, exploiting heat at 140 degrees and 4 to 5 kilometers deep. It is in operation since 2013. Turboden has a cluster of projects in Germany. There are other 6 plants in operation and 1 under construction. And more or less, this is the state of the art in terms of size of project in EU 27. So we are talking about more or less 5 megawatt electrical, and the other project in Germany are not combined heat and power, not all. District heating, according to the EGEC geothermal market report, these are the projects developed in the last year, and currently there are 400 geothermal district heating systems in operation. In the member states are quite 300, and the total installed capacity is 6 gigawatt thermal. But as you can see here, the number of the plants developed in the last year is quite stable, and only a few projects developed, despite the huge potential that you can see on the right side. This is a map of the available heat sources mapped at European level. And you can see in the EGEC market report all the characteristics related to the market development. But this chart could be most interesting in terms of future development. Currently, there are 360 projects in development or under active investigation in Europe. And so, as you can see, is a quite different history. It means that geothermal is growing in terms of expectation and in terms of interest. And geothermal is a good opportunity for district heating. We have seen for direct use of heat, but also in combination with industrial heat pump. I represent a manufacturer company, so from a manufacturer point of view, in my opinion, it will be a strong opportunity also the connection with the industrial heat pump. This is another report from the colleague from International Energy Agency that mentioned the opportunity for industrial heat pump connected for geothermal, but also for waste heat and so on, but in principle for heat pumps, industrial heat pumps development. Despite other sources like solar PV, when is and will be still dominated by Chinese supply chain, Europe can play a big role in industrial heat pump, developing the supply chain at European level. That could be an opportunity for the domestic country, but also for the export. Currently, Turboden is working in 52 countries around the world, so it means export, an opportunity for the export. Going more deeper in the expectation, how to scale up geothermal. So the heating and cooling strategy, electrification action plan, but also the clean industrial deal in general. There are a lot of dossiers that are under development at the European level, and we must take into consideration geothermal. And also launching the Geothermal Alliance. We have seen other alliances at European level that deployed good results. Supporting and promoting EU leadership in geothermal and heat pump manufacturing, and explained before, is an opportunity for the European manufacturer as itself. Risk mitigation scheme, as mentioned by the colleagues, is key in reducing economic and operational risk. We have a good example, is mentioned in France, but also in other countries. Incentives for geothermal heating. I've seen that there are some drafting in some countries relating how to fix, for example, an incentive for geothermal heat and leveraging with, for example, contract for difference or other sources, the difference in order to make geothermal business plan for geothermal plant more feasible. We need also to promote a new paradigm in approaching to district heating. Currently, geothermal is mature and strongly applied in agriculture, in residential buildings, and in district heating, not so much in industrial sector. And it is also a good opportunity to exploit this for industrial. Last but not least, increase plant capacity. What we have seen in the last 5 years, we have an internal study as Turboden. In the last 5 years, we quoting more than 100 prospect, 100 project for 2 gigawatt overall. And geothermal is showing higher mortality on smaller projects. So it means that the average capacity of higher success and probability in project implemented is in this case, more than 20 megawatt electrical. When I see megawatt electrical, I saw that there is a possibility to combine producing of electricity and heat. And so we have to take into consideration these opportunities. So for the future to scale up but we have seen also in the report of EIA the expectation of all LCOE reducing by a learning curve and reducing the specific cost. Last slide from my side. For those who have been involved in geothermal energy for years, I mentioned that Turboden is 40 years that involved in geothermal. It was exciting to help from the president of the European Commission mentioned for the first time ever geothermal. So it's a good period in my own, it's good momentum for geothermal, but we need to be more proactive in terms of policies and other development. And we need the project on the ground in order to show the potentiality of geothermal. Thank you. That's all from my side.
Thank you very much, Marco. It is indeed very encouraging to see that leaders at the highest level understand that we need to scale up investment into clean energy, including geothermal. And I think in this perspective, the IEA report is very important to give more visibility to geothermal. Before going to the audience, I would like to invite Giulia Cittadini from EGEC. Giulia, I'm very happy you are with us this morning. So I would like to invite you to share your views on the IEA report. And the question is, well, how do we move quicker? How do we accelerate the heat transition with geothermal? Please, Giulia.
Yes. Hello, everyone. Thank you. Thank you for the question and for the interesting discussion this morning. I'm very happy to be here and to say a few concluding words. The IEA report says that every country needs to move it up with their national clean energy policy agenda. And we at EGEC, we think that the European Geothermal Action Plan represents the solution, the key for Europe. The sector, as many of you said, is experiencing a policy momentum, which is very good, but it's not enough. We need to put in place some concrete actions, some concrete steps in order to unlock the potential that the sector has and that the presentation of François before showed us. In particular, and some of you already said that, I'm referring to harmonizing and simplifying the permitting process. We see that it's different in each member states, that it's usually it's really long, it's complex, many authorities, many laws are involved. We just need it to be simple and accessible. This sector also needs standardization of business models. We need an EU financial risk guarantee scheme to allow to unlock investments for business to develop geothermal projects. And we think that only with these actions it would be possible to effectively allow geothermal sector to reach the numbers that the EA report mentioned. And we need this to allow geothermal to be one of the source heating our houses, but also to go beyond it, because there are many applications out there, and geothermal can provide heat for industrial processing, for greenhouses, for example. So there are many applications, and we just need to unlock it. Yeah. So thank you for the attention. I look forward for the Q&A.
Thank you very much, Julia. And now, indeed, I would like to open the floor. So I will select a few questions from the audience. Questions are directed to individual speakers, but to all speakers, just feel free to take the floor. I'll start with one. It is for François. So if I read, how do we improve the business case of new geothermal projects, since this is a critical point for the deployment of the next gen technologies? François, please.
Thank you very much. Well, there are many options, and some of them I mentioned them in the policy priority area, and policymakers really have a massive weight on how to help improve this business case. But there are also other options which I haven't mentioned, that I have not mentioned in my presentation, and some include, for instance, lithium extraction. That's also geothermal lithium extraction from the brines. It's something that can be done in some cases, and there are a few regions that have been identified in Europe. There are, for instance, in Italy, in Germany, in the Rhine Valley, a whole area with some potential with high content lithium brine, and that can be extracted economically, and the potential is not neglectable at all. I mean, it's if you take all the different projects that exist in the world of lithium extraction, it represents about 5% of the expected demand of lithium by 2035. And just for Europe, whatever is in Europe, it's equivalent of 10% of what would be needed for projected EV capacity of batteries. So it's really big, and it can really improve the business case by having integrated lithium and geothermal projects together. So yeah, that's one thing. But again, really insisting on the de-risking and the remuneration schemes as well. And also what Julia said, also it's very important to think in terms more regionally at the European level about harmonizing also the permitting and working on industrial standards as well to try to reach economies of scale and really simplify and streamline permitting and development costs, reduce development costs this way also.
Thank you very much, François. I have a question now for Esbjørn. When looking at your projects, is geothermal district heating competitive with other heat sources? I think that's an interesting question. And then I also saw there was another question for you, Esbjørn. Yeah, are there certain examples of risk insurance subsidies that you would consider as best practices? I guess that the two are related. Please.
Yeah, maybe a quick answer to both. In Denmark, there are in different European countries, there are different heating regulations trying to protect basically consumers, which is super fine. In Denmark, the regulation is so that a district heating company has to compare relevant available heat sources, and they are only allowed to enter into the contract with the cheapest relevant available heat source. And it means that when we were to sell our geothermal project in Aarhus and our geothermal project in Greater Copenhagen, we were benchmarked on price against new biomass, against large-scale heat pumps, seawater and air-to-water. And if we couldn't meet those prices, it would have been illegal simply for the district heating company to enter into a contract with us. So the simple answer to the question is yes, it is competitive on price, but then there's also a then, and it's also to support what Ejik and others just said. it depends on the project. Those projects are very large, and the subsurface conditions are good, and we can be feeded into the district heating network in a good way, where we get a lot of hours. So you can say you get a lot out of your high capex investment. And I think that it would help speed up the transition if there were a so-called risk insurance scheme that could help carry some of the risks that are related to the first phase of a geothermal project. And that brings me to the answer to the second question. There are different schemes in place. They are right now looking into a scheme in Germany. There are a big scheme in place in France that has been there for quite a long time. And I think that if I were to be inspired, but other panelists can have other point of views, then I would look to France, because I think they have struck this balance about helping the business and the investors, but not entirely taking over the risk, for example, on the first well, because that gives incentives to do projects that are not really smart to do. So if I were to look after inspiration as a policymaker, I would look towards France to the best of my current knowledge. But others can chip in if they have other viewpoints, of course.
Yeah, thank you, Esborn. Actually, to pick up on that, there is a question for Alex. Alex, based on your experience in Vienna, how do you think we can accelerate the scale-up of district geothermal in Europe?
Thank you. I think we heard a lot of that in the presentations, and just to sum it up, I think knowledge and expertise is very crucial, on not only in the companies, where it is also very needed, because it is something new to drill 3,000 meters, and there is a lot to learn to do so, but also very much on the administration side, how to look into the potentials, how to look into the risk, and what is not a risk, and what do we need to regulate, and what do we not need to regulate. There is a lot of things we can do with knowledge. We heard a lot about de-risking. I think de-risking will help to boost and to also to make projects very much faster. When companies are have the security of their investments, it will help a lot. And the third thing is the enhancing and the speeding up the commissioning. What will also come with a higher knowledge, but going into one-stop shop, making the laws a little bit easier. The laws depending more on geothermal, and not putting water law and mining law and other laws together. This would help a lot, and speed up the projects very much.
Thank you, Alexander. Yeah, Julia mentioned that we need concrete steps. I think it's what you said. I have a question for Marco. So how do we scale up? But I think this is more from an industrial perspective. So how can we ensure that European industries can take up this challenge and grow?
Basically, we are discussing about turbines, heat pumps, drillings, and so on. It's all manufacture, and a clean tech manufacturer. So it's an industry that could be present and main actor in the next decades. So in the clean industrial deal, but also at policy level, we need to strengthen these points. But in my opinion, there are three main points to develop thinking. There is internal development. So we need to accelerate the project development. We have seen that administrative issue permitting a local level is one of the main barriers in terms of development of the project in terms of timeline. The second is support facility expansion and new expansion. For example, leveraging state aid or so on in order to have more manufacture. And the third point is to support export, because as you can see, there is an opportunity for domestic, but also for export. So with these 3 points, we can leverage, in my opinion, in a good way. Thank you.
Thank you very much, Marco. I have another and last question. It's for Tamas. Well, basically, it's about the outlook for the system in Szeged. So how will you grow? Can you add more users to the system? How will you increase the share of geothermal in the system? Please, Tamas.
Thank you. I think it's the same opportunity and also a problem for everybody. Just like in the case of Vienna, we have 37,000 apartments on the district heating grid, and about 80,000 apartments that are not on the district heating circuit. And that's a problem. That's a potential, and that's a problem at the same time. We are looking into adding new apartments, also new users. Currently, we are re-injecting water at about 40 or 50 degrees Celsius. So there's still an enormous energy content in that water. And we are thinking about adding new apartments, but laying pipelines and also refurbishing the apartments is a huge investment. So right now it is a plan for the future, but anybody who considers a new investment in a city with existing geothermal system, it's a no-brainer for them to think about whether the investment is close to a reinjection line or any facility where they can use basically free heat, waste heat, one that's already been used in the heating circuit and is being reinjected.
Thank you very much, Tamas. Well, I think looking at the time, it will be unfortunately the moment to stop our conversations, but I would like to thank our speakers. Thank you, François, for highlighting the potential. Also, thank you to Tamas and Alex for describing real cases in Szeged and in Vienna. So things are happening on the ground, but in the meantime, it's clear that it's time to accelerate the scale up of geothermal. And in this context, the work done by the IEA is very precious. So geothermal is a good deal for cities, for citizens. It is also a very good deal for European businesses. So we heard the case of Turboden. We also heard that we have the expertise to develop more projects on a large scale. This was the message from Energy, but we also heard that measures are needed to attract more investment and to bring it home. So now I will close the webinar. I would like to inform our participants that the webinar will be very soon available on YouTube. And also, I would like to invite you all to our EHP Congress. It will take place in Prague, early June. So please register, come to the Congress so that we can continue the conversation. So once again, thank you very much. Bye.